Welcome to today's live session. We'll be talking about land degradation assessment using Digital Africa. The session is recorded and will be shared with you shortly. So these are also other upcoming series. We'll be having a session on Sentinel-2 coming from next week. So Digital Africa was set up 4 years ago, and it's built on partnerships, providing Earth observation for decision making across different sectors. So Digital Africa is providing satellite data from these free satellite data sources, and they are availed in analysis ready format, which means viewers just to go and get some more information about what is already processed. This one, Digital Africa uses the Open Data Cube technology and powered by Amazon Web Services. So we are working with partners across the continent, and we are currently hosted in Johannesburg, South Africa, and we're working with partners across the continent. The program has developed these continental services, which are very key to unlocking a lot of potential on your end in terms of natural resource management. We are looking at cloud-free mosaics, GeoMat. We are looking at the vegetation climatologies. We are also looking at the coastline service, among other services. In terms of land degradation, this one, as per definition, is a persistent reduction in the soil nutrients and often accounted followed by loss of biodiversity. So in extreme case, we have desertification, and continent has been impacted a lot by land degradation due to prolonged drought, overgrazing, etc., etc. So we're looking at land being a very key component. And when we refer to sustainable development goals, it actually requires different governments to see how to address this particular challenge. And within Digital Africa, we are providing the various data sets that will help us monitor change in vegetation. And also we'll be going also in the sector of above soil organic carbon estimation. So looking at the land degradation by definition, and having worked closely with our partner, AFIGIS in Nigeria and Observation to Sahel in Tunisia, we are looking at all these factors as we can see. And where we are going towards is to avail the various services that we have at Digital Africa, the cloud-free mosaics, the vegetation climatologies, and also working with partners to see how to address the SDG 15.3. So we are looking at the proportion of land which is degraded over land. We have in Digital Africa resources such as vegetation climatology. We are also looking at change of vegetation. Also, we are looking at monitoring of mining activities just to see the trends over time and how different governments, different sectors can actually come together. So Digital Africa has also developed a course on the same in English and French, where we were able to co-develop with our partners across the continent. And here we are looking at ways of analysis, land degradation trends over time, the land cover trends, monitoring desertification, and looking at customized ways of looking at country level or specific area. So land degradation, that's on our end. This particular course introduces the land cover classification, forest monitoring, band area mapping using Sentinel-2 data, as well as desertification at the end of it. Looking at land cover maps, these ones have been provided by different services. We are looking at Esri, we are looking at the European Space Agency land cover maps, and this one we bring in Digital Africa, and we are able to work on specific use cases. So this case in point is in a case of Madagascar, loading the whole country, looking at the land cover of 2020 from Esri, from other land cover services. We can always see this complementarity of the services. And now looking at specific land uses, we can narrow into the city of Antananarivo and see the built-up areas over time as captured by these global land cover services. And then from this, now we can be able to calculate classes for each land cover, looking at how the cities have grown over time, especially the built-up areas, and the decline of the cropland over time as people are building houses, and as well as the drought, which has affected a lot of farming. So it means people are moving towards other other services. So the change in vegetation is a key area to investigate in most of analysis. And here, using our services, we can load the Landsat imagery that we have in our archives. And looking at an area of interest, we can look at the change of vegetation index, NDVI, or enhanced vegetation index, and we can come up with some visualization of what has changed over time. So this is just a case in point of an area of choice selection. We can see an area in the central islands of Kenya, just looking at the area where there's a forest, and you can see how much has changed over time. And this is just a notebook which gives us vegetation change over time and giving us some statistics of what has changed and areas where there is significant change. And in this particular example, it was shown that it was a forest area where it was impacted by the trees were cut for settlements, and we could see areas where there were significant changes. And this one was used by one of the forest agencies just to monitor their forest cover. We also have this monitoring change in forest using a tool which uses a global forest cover, and we're able to look at over 10 or plus years, and we can just go to this particular tool and choose an area of interest and look at the area of change. And you can even upload your own shapefile in case you're using it Esri. So you'll be able to visualize from the global forest change, and visually in South Africa, we can always look at the same using our maps. So this is just an example of one of our champions from Zanzibar. He was at the State University of Zanzibar, and he was sharing an example of a forest cover that they wanted to check. And currently he works for Zanzibar Environmental Management Agency. And he's mentioned, he's called Ali, and he's been working on looking at different areas. So this was just one of the examples of the areas they wanted to look at. We could see the forest area, the size, and they were able to see how they could actually use and generate a plot and look at the various statistics which were tabulated. And as you can see in the demo, they were able to see that over at least 10 or actually 23 years, how much was changed and how the indication was as the island moves towards avoiding urban heat. So forest cover will be very key for them to look at. And Zanzibar is quite a famous town for its, ecosystem. So we also have another tool for looking at a burnt area using Sentinel-2 data. This one now, we have an example of a locality in Ghana. And this one, the workaround is to just look at the area of interest, and it connects online to load data on the post-fire incident. And this one is relying on the dates that were identified by the particular use case. So in this particular case in point, loading the area of interest and generating the burnt area ratio and then generating the maps. So in this particular example, we have the notebook in the real world example. It's called the burnt area mapping, and it's able to, we move to the area of interest and loading the Sentinel-2 data. We're able to generate the maps and the post-fire instance, and even loading in the MODIS data, and finally having a normalized burnt area map of the area. And this is based on the incident that was recorded and even giving you statistics of how much has burnt and how much really you can use it for your other examples. So Digital South Africa also has worked with some other partners, like this one is near real-time burnt area mapping, which is just using the Sentinel-2 and Landsat 8 as well, but just trying to move beyond the normalized band ratio and also doing other comparisons of a relative band ratio. And this one, we were able to use it for an example of in St. George, South Africa, where we were given an incident of fire, and we were able to see how the area was. It was quite a big area, and looking at the time periods of 2018, October to November, we were able to identify how much was burnt, and this is the particular example I wish to showcase. So in the platform, you could access the sandbox, and in this particular case, in the sandbox, you have the near real burnt area notebook. And this is just the typical workflow. So Digital Africa is really empowering us to get these useful, you know, notebooks, workflows that we could use to empower our different data ecosystems in our different countries. We are looking at the teams, different countries, like the National Remote Sensing Center in Egypt, where they're able to convene different persons. We are looking at Agrinet, where they're really working very hard in Niger. Looking at other partners, CSA in Senegal. We're looking at Regional Center for Mapping. So this was the area which we had the forest incident, the fire. It was in Cape George, and this was typically the area which was burned. And we said, why not look at it in Digital Africa maps, and we could investigate the area, and we could see how much has changed over time for that particular example. So most of this example is driven by our experience. This was just an example of desertification analysis where we worked with the various teams. But in this particular example, we have an example of a Fonuga village in Benin. And here we were given an incident of somewhere which had really undergone land degradation over time. And we were able to run some notebooks. We have soil moisture, fractional cover, and vegetation change. And this one also we've implemented in our course so that when you attempt it, you'll actually see step by step. So you're able also to generate the fractional cover over time, which gives you the bare soil, the photosynthetic product, and you can see the changes over time in this particular area, and which has moved towards the one in orange, becoming relatively dry over time, and also bringing in the vegetation change detection, where we bring in NDVI, and also looking at the soil moisture. So here we have like 3 parameters: the surface wetness, the photosynthetic product from the fractional cover, and the precipitation. So in this one, we were able to see the precipitation for the area has generally gone down over time, and also has affected the surface wetness, and that desertification actually takes some time. And when we move forward, we are looking at how we could use the vegetation climatologies to help countries or institutions like Agrimet to generate their own food security bulletins, which will be a very key. And we are very happy to be joined by Bako Maman from Agrimet. We also have the tool on surface mining. This one now we're able to use the Sentinel-2 cloud-free mosaics and Sentinel-1, and also we're able to add the Digital Africa water observation from space. So this is just an example of Aparama forest in Ghana, where in this particular case, we're able to see this area experience a lot of mining activities, and it was typically around river, as this one is used in the processing of the minerals as described. And this is the typical workflow of the surface mining, where we load the data for a given direction, area of interest. We're able to calculate the change in vegetation. We're able to check the presence of water, and then we're able to identify the possible mining areas. So in the case of Aparama, we were able to see the activities over time, period of even of 3 or 4 or 5 years. We could see how the situation was and how it was, direction it was going. But by the year 2021, the government, through the Environmental Protection Agency, had put in some measures to curb these activities. So this is the typical workflow for the surface mining. We have this in the folder, the use case folder, surface mining, and we're able to see a particular change over time, the vegetation, and also this is just the notebook in the background, which is a Python file where it helps you to load the area of interest and even compute how much has changed over time, how much is degraded, and how much water was captured through the water observation from space. So after that, we're able to look at changing vegetation and identify the possible mining areas, which are very key, and using the change in the vegetation index, normalized vegetation index, we can be able to see the source. This is Aparama forest as our source, and we can be able to see the possible results where we can actually export. So this is the shapefile of the area which is loaded. And as you can see, capturing the whole boundary of the forest from the Ghana Forest Commission. And also looking at the area over time, loading the Sentinel-2 cloud-free mosaics, and also getting the change in vegetation over time and looking the trends, generally how it has been, and also being able to identify possible mining areas. And also, as we continue, we could also see how the activities are per year, the loss of vegetation, as can be seen, the one in red, and also the various interventions where the government took up the activity so that at least is regulated mining. So this was a case in point use case with the Ghana Statistics and the Environmental Protection Agency in Ghana, just showcasing what is possible. And also with your interest, I think we can be able to look at other areas. So we had another example. So you can even change the dates and run the script again. This gives you an idea of how dynamic the tool is to empower you to work on any example in Africa. We really want you to be empowered in using this platform to empower ourselves and the different institutions, government, academia, to all be able to use the platform. So as you can see, it's quite step by step and gives us the knowledge and how possible it is to work on different sectors, especially now in the mining and land degradation field space. So as we move to other examples, we had an example from Madagascar shared by a professor at the University of Antananarivo. He was able to share two locations, and here we were able to see the points and also just looking at the results of such an analysis. Basically the mining around possible areas where there was water pans for the process of minerals and looking the growth of activities over time and how well it is to document the change in vegetation and also guide the different agencies in just regulating the activities. They are very useful economic activities, but with some intervention so that we have at least sustainable mining as well as sustainable use of our resources. So that example, the previous one was on Ghana, was based on Aparama Forest Reserve. And we were looking at this time epoch of 2017 and 2021. And it was a use case to Ghana Statistics and Environmental Protection Agency in Ghana. Then looking at the training course that Digital Africa has developed on the land degradation, the modules covered the sessions. We look at land cover, forest monitoring, band area mapping, and desertification. And we worked with Observation Sahel in Tunisia. We had a general idea of a workflow where we could generate land cover products for each year. And here we were looking at Burkina Faso and Tunisia as an example. The first step being the land cover maps, the second step being the vegetation change. Then the third step, they're doing the cross-validation of the land cover and the vegetation index. Then the fourth step being the validation of what is possible, what has been generated. And the fifth component was to establish forest monitoring, especially showing the exact points where these would have occurred. So the typical workflow of these scripts, once we run them, they were able to give country level assessments, which are very key. And these are just first preliminary results that we could get. What is at the country level of land degradation, also capturing other land cover classes and how they change over time. And this is just guided by the products that we had, and also just showing you at country level how stable the land cover is, and also looking around the capital city, Ouagadougou, you could see areas which have experienced quite some degradation over time. So this one with these scripts, you can be able to generate at country level. But we had our reference years of 2014 to 2019 based on what we had, and we'll continue sampling this over time. So the land cover product, we could generate the land cover classification on the IPCC at country level. So this is an example in point of Ethiopia. just showing you the growth settlements over time, and you can see the trends in the settlements have always been high. However, the croplands we've seen a little bit stable or decrease, and this is quite a concern over time. And Digital Africa continues to add knowledge through our partner. We have the Geo Knowledge Hub, where we were working with in the series of presentations, and where I work closely with my colleague Joseph. Also, we have the training courses in English and French, which are very key to unlock a lot of potential. We also have a course on land degradation, and we'll later on add more knowledge. Then also these sessions are held in English and French. The next week we'll be looking at the Sentinel-1, and also we'll have our partner Anis, who will share on the soil organic carbon monitoring in English on the 18th and the 25th in French. And also we acknowledge the partners who've made Digital Africa quite a success. And also just pausing here for any question from our partners, or at least our partners could be able to add what I could not have covered. So Anis and Bako, you're welcome to add some inputs, as today we are joined with participants from far from Egypt. Welcome, Bako.
Hello, everyone. Thank you, Ken, for giving me this opportunity to share my idea. I remember that I did it during the previous call in French. So I think we want to thank Digital for all those initiatives and that are very, very well appreciated by our countries. My comment related to this presentation is when you talk about the land degradation, we know that it was well known that UNCCD is in charge of it, and for me, you talk about IPCC, and it will be good again to make the link between with UNCCD, because for the reporting on land degradation, I think they are in charge of it, and our countries are trying to find tools that will allow them to have a good report. And it's good sometimes for us to make the link with this expectation from countries. I noticed that during the previous presentation, we said that we technically work on this, and this is just what I want to share. And during the PDTT, I will be able to share my idea again deeply with the technical team to come with a service that is in line with the expectation of some countries that are already visited. So thank you, Ken, for the presentation. Over.
Thank you so much. I wish to welcome Anis to give his comments, because he'll be presenting on the soil organic carbon. And from the presentation, I was able to make some reference to Anis at OSS.
Thank you, Ken. Hello, everyone. Hello, and thank you, Ken, for this presentation, for today's presentation. So just I want to clarify things here, because even for my colleague Bako, so the OSS has contributed on this work, but not in the part of IPCC, because I think that Digital Africa here has been added a part related to IPCC. But our work is has been done based on the SDG 15.3 and 1.1 indicator based on UNCCD directories. And this work, or our work, has been done based on the ESA-CCI and also all relevant data related to this last one, means the UNCCD approach. So just Baku here in this presentation, Digital Africa has done, I don't know, maybe an effort related to, in order to just to expose or explain other different data, but it's not part of our approach shared with Digital Africa. So Ken, over to you, and thank you again for for this presentation, and see you in 18th and 25th for more details related to our soil organic carbon tool on notebook.
Inshallah.
Over to you, Ken. Inshallah.